Hello, my name is Cherry and I'm going to the questions from week 4 class. By the way, excellent questions. I'd be happy to explain how I would use a linked list to implement both a stack and a queue, along with the time complexity of their core operations. Linked lists are a fantastic choice for this because their dynamic nature allows for very efficient insertions and deletions at the ends, which is exactly what stacks and queues require. First, let's talk about the stack. A stack operates on a last in, first out, LIFO principle. The most efficient way to implement this is by using the head of the linked list as the top of the stack. Here's how the operations would work. For push, I would add a new item to the front of the list. This is equivalent to an insert head operation. It's a constant time, or O1, operation because it just involves creating a new node and updating the head pointer, regardless of how many items are in the stack. For pop, I would remove the item from the front of the list by performing a remove head. This is also O1, as I just need to reassign the head pointer to the next node in the list. For get top, which is peeking at the top item without removing it, I simply return the data from the head node. This is a direct access and is O1. And finally, checking if the stack is empty is just a quick null check on the head pointer, making it O1 as well. So, with this approach, all fundamental stack operations are highly performant. Now, for the queue. A queue is first in, first out, FIFO, which means I need to add to one end and remove from the other. This is where a doubly linked list with both a head and a tail pointer is ideal. Here's the breakdown. To enqueue, or add an item, I would insert a new node at the tail of the list. Because I have a direct pointer to the tail, this is a constant time, O1, operation. To dequeue, or remove an item, I take it from the head of the list. This is also an O1 operation. For the size of the queue, the best practice is to maintain a size counter variable within our class. I'd increment it on enqueue and decrement it on dequeue. This makes retrieving the size an O1 operation. Without this counter, we would have to traverse the entire list, which would be ON. And just like the stack, checking if the queue is empty is an O1 operation by checking if the head is null. In summary, by strategically using the head and tail pointers of a linked list, we can build very efficient stack and queue data structures where all the primary operations run in constant, O1, time. Thank you.